All right, what's up, guys? This is the second video of two-dimensional motion without launching anything yet. We'll get into that with the launch angle and dealing with triangles and things of that nature. So a person moving, you can come in. You're good. You're good. A person on a moving walkway travels with a velocity of 2.2 meters per second horizontally. That same person has a negative 0.5 meters per second squared acceleration in the vertical direction. The time is 6.0 seconds. There is no horizontal acceleration. So first things first, let's draw our chart. Drawing our charts. Remember, x-axis, y-axis, VIX, VFX, acceleration, time, displacement of x. And then, initial velocity of y, final velocity of y, acceleration of y, time, and displacement of y. Okay, so let's go in and look at what we need to fill in, okay? So, first things first, what's the first number we come up with? It's 2.2 meters per second horizontally. So that's going to tell you it's got an initial velocity of 2.2 meters per second on the x-axis. Okay. All right, next. What's the next number that we have? The same person has a negative 0.5 meters per second squared acceleration in a vertical direction. So now you're going to the y-axis. So negative 0.5 meters per second squared. Okay. The time is 6 seconds. Well, that's pretty self-explanatory. 6 seconds. So whatever happens in the y-axis time-wise has to happen in the x-axis as well. So that goes under both. All right. And now the next thing, no horizontal acceleration, which tells you that this is 0.0 meters per second squared. It also tells you that the final velocity of x also 2.2 meters per second. Okay, so that's that. So you filled in what you know, what you've been given and what you know. Now you need to go ahead and solve for the displacement of x, displacement of y, initial velocity of y, and final velocity of y. Sorry, my bad. All right. So, a couple things as we start to do this. So, keeping in mind, so first things first, let's just do d of x. So, d of x equals vi times t plus 1/2 of at squared, right? So the displacement of x equals the initial velocity times time plus 1/2 the acceleration times t squared. So d of x equals 2.2 times 6 plus 1/2 of 0, then you're done. You don't even need to go any further, okay? And so your displacement of x is going to be 2.2 times 6, which is 13.2 meters. And it is a positive 13.2 meters. So your d of x is 13.2 meters. All right, so that's that. Now you need to solve for final velocity of y, initial velocity of y, and what the displacement will be in the y direction. All right. So you know that's 13.2 on this side. You know that in the end, it's accelerating to, on the y-axis, you're accelerating to negative 0.5 meters per second squared. Okay. So with that understood,